All right, here we go. We're on 2B.3 inverse functions, part B, examples 5 through 10. Okay, so we're going to start with example 5. Example 5, we are talking about interpreting what it means, what our function notation means. So it says, let C of M be the cost in dollars of M ounces of mangoes. What do the following statements mean? So what we're going to first do is make sure we understand what C and M are. So C is our M is our input. Let me write that as input. So we're going to identify our input and our output. So our X, our independent and dependent variable in this case. So our independent, which is our input in this situation, is going to equal our ounces of mangoes, right? Ounces of mangoes. All right, our output, our dependent slash our output, that's going to equal our cost, right? It's going to be the cost in dollars. In dollar bills, y'all. Okay. All right. So first thing here, we're going to identify the input. What does the input mean? And then identify what's the output. Okay. So when we look here, this is our independent. This is our dependent, right? So our input, our independent says 12. What does our independent mean? Ounces of mango. This is our output. What does our output mean? Cost in dollars. So when we write a sentence, we're saying, what is this telling us? What is this function notation tells us? It's telling us for, I wrote fro, not for. I don't need you to tell me, I see it. For 12 ounces of mangoes, it will cost 75 cents. Does that make sense? Okay, so let's do it again here. Identifying my input and my output. So this is my input, my independent, and my dependent. So here, what is it telling me? It says for 8 ounces of mangoes, I guess there's an E in there, of mangoes, it will cost 50 cents. Okay, that's it. All right, now inverse. So when you have your inverse, your dependent and your independent are switching places. So for here on my inverse, this is now my dependent. This is now my independent. So when I read this, it's saying if you have $3, you can buy 48 ounces of mangoes. So for $3, you can buy, or you can buy, or you will buy, you can buy 48 ounces of mangoes. Okay? Easy enough. Again, your inverse means that your dependent and independent have switched roles. So my dependent is 75.75. My independent is 12, which these right here are inverses of each other, right? So we can write it as 75 cents will buy 12 ounces of mangoes. Okay, so that's the basic interpretation, is making sure you know what your independent is and your dependent, and then applying it in the correct location. Okay, all right, let's look at another example. So it says, suppose W equals P of X is the average of the daily quantity of water in gallons required by a palm tree of height of X feet. Okay, so it says, what does the expression P of 25 mean? So when I look at this, it's telling us we got to make sure we know what's our independent and what's our dependent. So we're using P of X. So if I'm looking at P of X, I know that my independent and my input is going to be my height in feet, the tree height in feet, right? That's what that's going to be. And then my output is going to be P of X, right? So the P of X is my output, and what that stands for is the quantity of water. So water in gallons required for the palm tree is going to be the output, my dependent. So for this problem, it says, what does the expression P of 25 means? Okay, so if I have P of 25, it's saying P of 25 equals some W amount of gallons of water. I don't know what it equals, but I know that it equals some gallons of water. And so what this is telling me, it's going to be the average, when I know what W is, it's going to be the average daily quantity of water required for a 25-foot palm tree. Okay, that's all I can tell you what it means. Now, what does the expression P inverse of 25 represent now? Okay, so P inverse of 25, if I was to analyze this, remember it means when I have the inverse, that means that these two roles are switching. So now it's a W instead of a number, which means that I now know how many gallons, right? I now know the gallons that I have, but I don't know how tall the tree I have. So this is saying P of inverse of 25 equals a tree of some height. I don't know how tall it is. Equals X feet. Because I don't know how tall the palm tree is, right? So X feet. So when I write that as a sentence, I can write it as, and guys, please don't hesitate, don't question me on my, well, you can question me, correct me also on my grammar, but don't make fun of me. Help me fix it. Okay, so the height, well, how can I write this? The height of a palm tree, palm tree that requires 25 gallons of water. So that's what the inverse is saying. Okay? Now it says, what does the equation P of V equals 50 tell you about V? And rewrite the equation in terms of P negative 1. Okay? Well, what used to be there? X. And what did X mean? X meant the height. So in this case, V equals X, right? So V is the height of the palm tree, that would need or require, that will require, that got a little weird there. I got to really figure out a better way of holding my pen. That will require, and then our output is 50 gallons of agua. Okay? And then last it says rewrite the equation in terms of inverse of P. So for this, its inverse would simply be P negative 1, and I'm switching my input and my output. So P negative 1 of 50 equals V. Okay? It says palm trees are an average of Z feet high, and a tree average height requires K gallons of water. Represent this in terms of P and P negative 1. all you're doing is substituting in new values. So palm tree height and tree average. So this is your new X. This is your new W. That's all it becomes. So P of Z equals K, and therefore inverse of P would be K equals Z. Okay? It's just being able to toggle between the two and using the words. All right, so continuing on with our interpretations here. So let's look at some more. So still using our Z and our K from part D, what would the following expressions represent? So if I said P of 2Z, what's happening here? Well, what did I do? I doubled, right? So it's saying here, you're looking for water double the average height, right, of a palm tree. That's not how you spell palm. Of a palm tree. Okay, here it says 2P of Z. Well, P of Z by itself, that equals K. So this equals 2K. So if this equals 2K, what is this saying? It's saying double the water for an average height of a palm tree, right? So we're going to double the required water for an average height palm tree. Who knew that just a few little letters would equal all these words? Okay, I do not know why I'm maybe I should capitalize. I'm going to put periods at the end. All right, here we go. So now it says P of Z plus 10. So the ending result is going to be water, right? So now we're looking at the water for a palm tree. And what did it do? It grew an additional 10 feet. Water for a palm tree after growing 10 additional feet. Additional feet taller than average, because it's still talking about the average. Okay, now P of Z plus 10. So now this is K plus 10. And what does K represent? Well, K represents the amount of water required, right? So if K represents the amount of water, this is saying we need 10 gallons more water, right? So we need 10 gallons more water for an average height palm tree. Okay? All right, now it says the inverse. So if I'm now looking at the inverse, remember that means that my input and output have switched. So let's talk about what it would look originally. So if it says the inverse of 2K, well, that means that I had P of Z equal to 2K. That means 2K used to be my output. So what does that mean in terms of this problem? Well, what did we say it meant for 2K? It's going to be twice the amount of water, or double the amount of water for a tree, but we don't know its height, right? So double or twice, let's say twice. Twice the amount of water for a tree that is, we don't know how tall it is, z feet tall. Is what we need. All right, so this one says P inverse of k plus 10. Well, what would that look like as a non-inverse? So as a non-inverse, this would be P of z equals k plus 10. Well, haven't we seen k plus 10? And what did it mean when we had k plus 10? It meant this, right? 10 gallons more of water needed for a tree of average height, right? But this time is of average height of z. It's emphasizing the fact that our z is our unknown. So we'd write 10 gallons more water than needed for a tree of average height of z. That sounds something like right. Okay. Here we have P inverse of k plus 10. Ooh, so this one got a little tricky. So P inverse of k plus 10 equals. What is this telling us to do now? Dun, 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 dun. What do you think that resembles? Well, if you said that this is going to come out to be where we're adding the 10 to our x instead of our k, then you are correct. So this becomes P of z plus 10 equals k. Have we not did P of z plus 10 equals k? Why, yes, we have. And it was the water for a palm tree after 10 additional feet taller than average. Same thing here, but you can word it as differently as you like, but it's pretty much the same. So we're saying we're looking for water needed for a palm tree, 10 feet taller than average. Notice that the wording is slightly different, and the reason why it's slightly different, it's just because we're interpreting the inverse, but we're using what we know it means to help us interpret. Okay, so the inverse of k minus 2, again, remember this means your x and your y are switching places. So what affected your y is now affecting your x. So this is going to become P of, not x, your input and output. Sorry, I got to stop saying x because it can be any variable. So it'll be z minus 2 equals k. Well, when we had, I don't think we had a z minus 2 now. Look. Nope, we did not. So this is a whole different one. So what is this telling us? Well, it's telling us water. Our inverse is telling us the water needed for a palm tree that is 2 feet shorter than average. 2 feet shorter than average. Okay? And those are our interpretations. So again, takeaway here. When you have your function notation, just your regular function notation, you're interpreting what the 2 and how it's impacting your value. So water doubled the average height of a palm tree. Okay? Here, 2, P of z, double the required water for an average height of a palm tree because I'm changing the height. P of z was the water, so I'm doubling my water. Here, I was doubling the height because z represented my height. Then we have P of z plus 10. So this time again, z represents the height, so I'm adding additional feet to the height. Here we have P of z plus 10 on the outside, which is P of z equals k. And so we have K plus 10, which means we're adding 10 gallons more water for an average height palm tree. Now we're on to the inverses. So with the inverse, we interpret it in terms of what would the original function be by switching the roles of our input and our output. So my input here is 2K. To go back to the original, my input is just going to be Z because this is what this is equal to, Z. And so P of Z equals 2K. And if I have P of Z equals 2K, what does that mean? It means twice the amount of water for a tree that is Z feet tall, because I don't know how tall it is, but that's what it is. Then we continue, and we flipped, reversed, and then explained in words. This is where you do your best to explain, okay? Make sure you are clear. I'm not sure on how much they're grading on grammar. Just make sure that it's legible, and for the most part, it makes majority of the sense. Okay. All right. So on the next part, it is just more practicing with table evaluation. So if I have the inverse, but I only have the table of the original, that means I'm going to go to the y first and look for the x. So I'm going to go to f inverse of -4. So I go to -4, and I get that the x is 5. So the answer here is 5. Okay, if doing it that way doesn't help you, then you can rewrite it. So inverse of -4 equals, sorry, this should be equal sign, equals x, or you can flip it and have f of x equals -4. So when you go look for when does f of x equal -4, that's going to be at x equals 5. So either way, your answer is going to be 5. Okay, let's try it again here. G inverse of at 6. So again, I'm going to go to y, and I'm looking for my x. So I go to the g of x first. I get -6, and its output is going to be, oh, I'm sorry, it says +6. I go to +6, and its output is going to be 8. So my answer again is 8, and you can verify yourself by finding the inverse, which would be finding the original function, which is f of x equals 6. So when, not f of x, g of x, so when does this function equal 6? So when does g of x equal 6? Well, g of x equals 6 when x equals 8. Okay, that's it. That's evaluating with just the table. If you wanted to create another table and write out your inverses, by all means you could, but there's no need. Now we're combining our composition with this, so we're going to do g of 1. So we're going to start from the inside, g of 1. So I go to 1, I get -3. So now I'm at f inverse of -3. So this, I went to x and then to y. Now I'm going to go to my y, then to my x. So I go to -3, which is right here, and its x is 3. So f inverse of -3 equals 3. Okay, we're going to go on the inside, f of 0. So I'm going to go to 0, and I get -1. So that becomes g inverse of -1. Now I'm going to go to my y first. So I'm going to go to my y and see when do I get -1, and I get -1 when x equals 4. So my final answer is 4. And that's how that goes. All right, so we're going to find the inverse of a rational function. Finding the inverse of a rational function, you're doing in theory the same thing, where you're switching your y and your x and then getting y by itself. But you have to be a little careful because there's a little more steps to isolating the y. So first we're going to switch. So when I switch those variables, I'm left with x equals 2y plus 3 over y plus 2. I'm going to make that a little prettier. Okay, so we have y plus 2. We're going to multiply because we have to get our variable out of the denominator. So we're going to multiply both sides by y plus 2. So multiplying both sides by y plus 2. When I multiply both sides by y plus 2, I'm left with x times y plus 2 equals 2y plus 3. Okay, I'm going to distribute my x to get rid of my parentheses. So we're left with xy plus 2x equals 2y plus 3. Okay, The next thing we want to do is move all variables that have y to the left and all variables that don't have y to the right. So I'm going to be subtracting 2x and subtracting 2y. After I do that, I'm left with xy minus 2y equals 3 minus 2x. Okay, now I'm going to get y by itself. In order to get y by itself, I'm going to factor out y. When I factor out y, that means it's moving to the outside, and what I'm left with is x minus 2 equals 3 minus 2x. So now I can isolate the y because it's a factor. It's no longer part of a term, it's a factor, it's by itself. To get it by itself, I'm going to divide both sides by x minus 2. Divide both sides by x minus 2. So y is now by itself, so I can write my inverse. So since y is now alone, I can say that my inverse equals 3 minus 2x over x minus 2. And that is my inverse function. Okay, so now that I have my inverse function, I can also state the domain of my inverse function. So my domain here is that x has to be, and x cannot equal 2, because if x equals 2, then it would make my denominator 0. And remember, it's a no-go for 0 in the denominator, okay? And my range is just all real numbers. So it goes from negative infinity to positive infinity. The output is endless. Okay, so it says find the domain and range of f of x. So the domain and range of f of x, here it's negative 2, right? So I know that x cannot equal negative 2. So of the original function, we know that x cannot equal negative 2, because if I plug negative 2 in, it would make my function equal to 0 in the denominator, and that's not allowed. Writing that in set notation, or not set, interval notation, remember that looks like this. It goes from negative infinity to negative 2 union negative 2 to infinity is where my domain lies. Okay, my range here, oh, I lied on the range here. There is an asymptote. So for your range, what your y can equal, let me go ahead and erase that lie. Okay, your range depends on your leading coefficients and the degree of your numerator and denominator. Because the degree of our numerator and the degree of our denominator are the same, our range depends on its leading coefficients. And our leading coefficients are 2 and 1. So we know that there's a horizontal asymptote at y equals 2. So we know y cannot equal 2. So therefore our range is from negative infinity to 2 union 2 to infinity. Okay, because we know this, that means that for our inverse, it's going to be the opposite. So since our y couldn't equal 2 on our original function, for our inverse, the domain can't equal 2. Since our x can't equal negative 2 on our original function, that means on our range, y cannot equal negative 2. They switch roles. And you can see here again, if you were to look at your horizontal asymptote would be at negative 2 because your degrees are the same and it's based off of your leading coefficients. All right. And last but not least for this section, we have to, or not, pretty sure there's no slide, but my pen's not taking me there. Take me there. I want to go there. Okay, so I'm going to, okay, what to do. If a function is not one-to-one, then its inverse does not exist, okay? However, if an appropriate restriction on the domain is made, then we can find an inverse that is also a function. So for example here, we look at example number 9, and we have y equals 2 minus x squared. Well, 2 minus x squared is not 1 to 1 because it's a quadratic, which is a parabola, which is a U-shape, and clearly fails a horizontal line test, right? However, notice we put a restriction on it, okay? That restriction is saying for x value greater than or equal to 0. So for this y, for this f of x, we only can have x values that are greater than or equal to 0. So we can have 0, 1, 2, such and such, right? 3, you get it? But we can't have any of the less values. So the f of x values that we're gonna end up with, I guess I can go up to 4. I'm gonna plug in 0. Well, 0 squared, so 2 minus 0 is gonna be 2. Then we're gonna plug in 1. 1 squared is 1. 2 minus 1 is 1. We're gonna plug in 2. 2 squared is 4. 2 minus 4 is negative 2. We're going to plug in 3. 3 squared. 3 squared is 9. 2 minus 9 is negative 7. And just for 4, 4 squared is 16. 2 minus 16 is going to be negative 14, right? So I'm going to plot my my f of x. So I'm going to go to 0, go to 2. I'm going to go to 1, 1. I'm going to go to 2, negative 2. And I'm going to go, I can't go to 3, 7. So here we are. We're going to cross. So we're going to do our very best and cross right here. And then 3 is going to go all the way down. Pew, pew. Okay, so now that part's done. Now I'm going to graph the inverse. So I either can create a table or just graph it. For the sake of our notes, I'm going to visually show you the inverse first before I graph it. So the inverse here would be the square root function. And I just know that because the inverse of squaring is square root. But to find the inverse, we're going to switch our x and our y. So we have x equals 2 minus y squared. I'm going to isolate the y, so I subtract 2. And we're left with x minus 2 equals negative y squared. I'm going to divide everything by negative 1. So when I divide by negative 1, I'm left with positive 2 minus x. So if I divide by negative 1, x becomes negative, 2 becomes positive. So I'm left with 2 minus x equals y squared. Now I'm going to take the square root. By taking the square root, I'm now isolating the y. And so now y is going to be by itself. So I now know that my inverse function equals the square root of 2 minus x. Okay? The square root of 2 minus x has a restriction of its own, and that restriction is x cannot equal, x has to be greater than 2, greater than or equal to 2, because under the square root you cannot equal, I say greater than, less than or equal to. I can talk, guys. Less than or equal to 2, because I can't have negatives underneath the square root. Okay? Now, to graph this, all I'm doing is inverting these points, right? So instead of being at 0, 2, I'm now at 2, 0. Instead of being at 1, 1, I'm still at 1, 1. Instead of being at 2, negative 2, I'm now at negative 2, 2. So we have our square root function heading this way. And we're going to pretend that your teacher graphed this so perfectly that it is symmetrical along the y equals x line. And notice how it does intersect on the y equals x line, and it's drawn beautifully. Okay, so I found my inverse function. I graphed my inverse function. I proved it visually that they are inverses of each other. This is my inverse, and this is my original. Looks glorious, okay? So now I should be confident enough to establish and describe what takes place. So the domain for my original was x had to be greater than or equal to 0, right? Which made sense for this problem. So if I had to describe the domain of the original, its domain is from 0 to infinity, right? And its range, however, since it's declining, my range is from negative infinity to, and my max value is 2. Well, notice how for my inverse, it's the opposite. My x is less than or equal to 2, so my x goes from negative infinity to 2 and stop. That's my domain, and my range is going to be the opposite. My range is from 0 to infinity. So my range starts at 0 but continues to infinity. And that's going to always be true for your inverses if both are a function. Okay? All right, so it says here, suppose f of x and g of x are one-to-one functions. So we have f of 3 equals 5 and g of 5 equals negative 3. Excuse me, I'm getting tired. Negative 2. Can you determine whether f and g are inverses of each other? Explain why or why not. Okay, so in order to do this, we have to make sure we understand that the point 3, 5, so if we have f of 3, 5, that means that the point 3, 5, right, is on f of x. Okay, so the point f of 3, so the point, 5 of 3 has to be, or would be on the inverse of that. Okay? And so if g of x was the inverse, that means that g of 5 would have to equal 3. But does g of 5 equal 3? No. So that's what we're stating. So if the inverse equaled g of x, then g of 5 would have to equal 3. So since g of 5 doesn't equal 3, then, and therefore, f of x and g of x aren't inverses. Well, let's not use aren't, are not inverses, are not inverses. Okay, so that's just logic. So trying to explain what you're reading is going to come down to making sure you understand the vocabulary here. So this says that f of x and g of x are one-to-one. That was one thing, that's the first thing that has to be true. They have to be one-to-one in order for an inverse to exist, okay? So if it tells me that f of 3 equals 5 and g of 5 equals negative 2, can you determine whether f and g are inverses of each other? Explain why or why not. So this tells me f of 3 equals 5 tells me that the point 3, 5 is on the f of x. So the point 5, 3 would have to be on its inverse, okay? If the inverse of f equals g of x, then that would mean that g of 5 would have to equal 3. So since g of 5 doesn't equal 3, g of 5 equals negative 2, then, and therefore, f of x and g of x are not inverses. So it's more of a logic, not a computational situation that we're looking for. All right, that concludes our notes.